Here we are back in our CalcEngine app, and remember we have our dynamic helper class that knows how to parse apart a statement, find a handler that knows how to deal with a keyword, ask the handler to do the operation, and then our dynamic helper can build the output. Now again, we've done all this in terms of the interface, so we can actually extend the ability of dynamic helper very easily. So let's imagine that we want to have another statement in here, something we've never done before. Maybe we want to support a statement that can actually raise values to a power. So we use the keyword power, and we want to say something like 5.0, 2.0. In other words, we want to square the value of 5.0, right? Multiply 5.0 times itself. Right? So the result of that would be something like 5.0. Let's say we use the caret for power of 2.0 equals 25.0. So we want to build a handler that can do that work. So what we'll do is we'll add a new class to our project called power of. Create the class, and we're going to have it implement our math processing interface. We'll go ahead and add all the methods, say all three of them. So now we want our power of implementation here to do the work necessary to plug into our dynamic helper. Well, the get keyword, well, the keyword it understands is power. The symbol that it returns is that caret. And then to do the actual work, we'll use one of the built-in math libraries called POW, P-O-W. And to POW, we'll pass in our left val and our right val. So we now have a class, power of, that knows how to raise values to a power and conform to our math processing interface. So now to add that into our dynamic helper, all we have to do is go back to our main. And here where we new up the adder, we're going to go ahead in that same array we passed in there. We'll now new up power of. And that's all we do. Create an instance of a class that implements the interface, and then make dynamic helper aware of it. Now when we run this, we should see that both the add statement and the power statement get handled. And you see there that we do. The add statement added the numbers together correctly. The power statement raised 5.0 to the power of 2, producing 25. And you see, and that's where the power of interfaces really shine through. That ability to take a problem, abstractly model it in terms of its individual pieces, model the contract to fulfill those pieces as an interface, and then you can very easily just build implementations of the interface that focus on a very specific set of work. And then you can leverage a lot of that existing work that you've already done to get very powerful results with only a little bit of incremental work each time.